Kinematics 2 is all about the graphs of motion, and in this video we will discuss, investigate the basics of the velocity time graph and the position time graph. So only level 1 and 2 questions. What is the absolute basics of position time graphs and the velocity time graphs? So we'll start off with the position time graph, and the most important characteristics or properties of a position time graph is to know the different shapes for each type of motion. So please memorize these different shapes, because in a test or exam, when we ask you to draw a position time sketch graph, which is not according to scale, but you need to get the shapes of each type of motion correct. So let's start with the first type of motion on the far left of your screen. That is when an object is stationary. When an object is stationary, it is just a straight horizontal line, meaning that that object is keeping that position for a few seconds or a few minutes. So the object is stationary. Now, the object can also be stationary on the negative side of the 0 point. So if you take the origin to be the 0 point where the object, let's say, may have started its journey, any horizontal line above that or below that will mean that the object is stationary at that position. A straight line with a positive gradient means that the object is moving at a constant speed. But that is also true for any straight line with a negative gradient. It is also moving at a constant speed. It is just moving in the opposite direction. So any line, any straight line, whether it's below the x-axis or above the x-axis, if it's a straight line with a positive gradient, like any yellow line that I've drawn here on the screen, doesn't matter whether it's above the x-axis or below the x-axis. If it has a positive gradient, then it means that object is moving in the positive direction. But if you have any straight line moving down with a negative direction, let me use blue so that you can see this. So if you have any line, whether it's above the x-axis, below the x-axis, coming from the origin or not, any straight line on a position time graph with a negative gradient, whether it's above or below the x-axis, means that this object is moving in the negative direction, in the opposite direction of the initial motion. So any straight line, the object is moving at a constant speed. Then the third type of motion is if the object is accelerating, is moving faster. So the yellow line here represents an object that is moving faster in the positive direction. And if an object is moving faster but in the negative direction, your shape will be this curve but downwards. Again, guys, this does not matter whether it's below the x-axis or above the x-axis. So even if I have this yellow shape below the x-axis, if you see this shape, then it means the object is moving faster. Even if I see this shape above the x-axis, if you see this shape, then it means the object is moving faster in the opposite direction. So these two curves represent objects that are moving faster. Then we also have this curve. This is an object moving slower in the positive direction. Now, the mirror image also means that the object is moving slower or slowing down, only in the negative direction. Very important, last thing about when we sketch position time graph is to remember that the gradient represents or is equal to the velocity of the object. So you can see with this second type of graph, we have a constant gradient. So the gradient, which is a positive gradient, means that the velocity will be in the positive direction. And then the purple line with the negative gradient means that the object is moving at a constant velocity but in the negative direction. With these two last type of graphs where you have curves, the gradient is not constant, which means the velocity is not constant. And with the last two graphs, that means that your object is accelerating, and that is why you do not have a straight line with a constant gradient. So curves on a position time graph means the object is accelerating, whether positive or negatively, or slowing down or moving faster. But because you have a curve and not a constant gradient, it means you do not have a constant velocity, but you have acceleration. Right, so let's look at an example of a position time graph, and we have Shalom. She starts at a house and moves in a westerly direction. So start at a house means that this 0 point represents her house. Now, let's talk about the direction. She starts at her house and then moves west. That means that up in the positive direction of your y-axis, that is west. And that is how we deduce that west is the positive direction on this graph. Now she moves west, she moves up in a positive up to 7 seconds. And then you can see that there's a change in direction, because then from there on the graph comes down. From 7 seconds the graph comes down. So that is the point where Shalom changes direction from west to east, the opposite direction. And because east is moving in the direction of the negative y-axis, we know that east represents the negative direction. So on a position time graph, how do you know, or where do you know to find the point where the object changes direction? For this scenario, changes from west to east. That will be here at 7 seconds when the graph itself changes direction. So everything up on a position time graph, whether you start below the x-axis or above the x-axis, it doesn't matter where, as long as your line graph, or the line of your graph moves upwards to the positive side, that represents the positive direction. And then the moment that that line comes down, that then represents a negative direction. Okay, so that is how to find the point where the object changes direction. It is the point where your graph itself changes direction. Now, let's look at all these little theoretical shapes that we now have in our brains because we have memorized it. Let's look for stationary types of periods of times where Shalom was stationary. Well, the first one is here between 0 and 2. Whenever you see a horizontal line, that is when you know the object was stationary. Then there's a curve, an upwards curve. Now, if you look here, where's the upwards curve? That will be this one. The third one from the top. Let me just get a pen. There. So that will be, no man, you can't see anything. So that will be this one. So this upwards curve, this is this one. So you need to learn that if you see this shape, that means the object is moving faster and it's moving west because it's an upward shape. Then the next one is a straight line. So a straight line is the second graph. that means it's a constant velocity or a constant speed. Then we have another straight line. The gradient is just a little bit less. So remember, the gradient represents the speed or the velocity. And then we have another curve. Now, if you see that curve, you need to remember that a curve like that, if you have a line going like that, that represents a slowing down. That is what that type of curve means. So you need to learn which type of curve or straight line means you have a constant speed, a constant velocity, which curve represents going faster, going slower. Now, we've already said that at this point is when the object is changing direction. So from there, the object must go from west to east, but now it's going faster. So again, it is this shape. It is going faster in the opposite direction. Then again, you have a straight line. Straight line means it's a constant speed, but it's a negative gradient, so it is in the direction east. Remember, we said east is negative. And then again, we have a curve. Slowing down is this one in the opposite direction, and then again a stationary motion. So you need to be able to read a graph like this and identify the time intervals where the object is moving at a constant speed. You need to know that if it's a straight line and the gradient is positive, it means that the velocity is in the positive direction, which is west. And if you see a straight line which has a negative gradient, remember the gradient of a position time graph means that represents a constant speed. But because it's a negative gradient, it means the object is moving in the negative direction. We can use our position time graph to find the average speed and velocity. Now remember, speed is distance divided by time, and velocity is displacement divided by time. So if you have a position time graph, where will you find the total distance and where will you find the total displacement? Now, if Shalom starts here, this is where she starts. It means that the total distance that she will walk or run or whatever is the actual path that she takes. So this whole thing is her total distance. So total distance will be from there, from where she starts, she moves 5.2 meters west. Then she turns around and then she walks back 5.2 meters plus that 3 meters. So the total distance that she walks from beginning to end is 5.2 meters up. Then she turns around and then she moves 5.2 and 3 that equals 8.2. So all in all, her total distance is 13.4 meters. So if you calculate the speed, her average speed will be the total distance, which is 13.4 meters, divided by the total time. So the total time you find here on your graph, that is your total time. And that will just give you her average speed. So remember, how do you find the total distance this person covered in 15 seconds? This is where she started. She walked 5.2 meters up in that direction. Then she turned around and moved from there to there. So you need to add this distance to that distance, and that will give you her total distance. Now displacement is something totally different. Remember that displacement is a vector, and displacement is a straight line from the start to the finish. So she started here, she walked that direction, then she came back this direction, but displacement, very important, is where she started and then up to where she finished. So she started at 0 and she finished at -3. So that is her displacement. So her displacement is -3, but we can't leave our answer as a negative. So the -3 becomes 3 meters east. Why east? Because remember, east is the negative direction. And you can see that the arrow representing her displacement points downwards to the negative direction. So her displacement from start to finish is just a straight line, 3 meters east. So if you then want to calculate the velocity, velocity is total displacement over total time. Remember, where do I find the total time? Total time is 15, because that is the total time of this whole graph. So 3 divided by 15 will give you 0.33 meters per second. Again, east. Why east? Because when you calculate the average velocity, the direction of the average velocity will always be the same direction as the displacement. So when you need to find the direction of an average velocity, it will always be the same direction as your displacement. We can also use a position time graph to calculate the gradient of all the straight line areas. Remember, we can't do it with all these curvy areas, because then the object is accelerating and it's not moving at a constant speed. But when the object is moving at a constant speed, it will give us these straight blue lines like you see on the screen. So if I want to calculate the speed or velocity between 6 and 4 seconds, I can just calculate the gradient between 6 and 4 seconds. So then you just need to show your math skills. Guys, this is 100% math. There's no science here. If I ask you to calculate the gradient there, you just do normal math. It's y2 minus y1 over x2 minus x1. It's a mathematical skill. Calculate that gradient and there's your answer. To interpret your answer, that is science. So I got the gradient for that line, that first blue line, as a half. So the gradient represents speed. So the unit for speed is meters per second, and because I got a positive answer, I know that positive for this graph is represented by the direction west. So because I got a positive answer for my gradient, I know that that represents a positive velocity west. Now for the second line, I can predict that I will have a negative answer. So for the second line, I work here. So again, I have x1, y1, x2, y2. I calculate the gradient between 10 and 12 seconds. It must be a negative answer, because a line like this represents a negative gradient mathematically. So I got -3 for my gradient, and now we need to interpret the answer scientifically. The gradient represents speed. The unit for speed is meters per second, and because you got a negative direction, we know that you can't leave your answer as a negative answer. You need to substitute the negative sign with the word east, because east is negative for this graph while west is positive. So if you get a negative answer for your gradient, you can't leave it as a negative. You must rewrite your answer with the correct unit and then you need to write the word down, in this case east, that represents the negative direction. Let's move on to velocity time graph. So again, we start with the basic shapes. Remember, in a test or exam, most of the marks go towards the shapes of the velocity time graph. So on the left-hand side of your screen, we start with an object that is stationary. Now, this is the 0 point of a velocity time graph. So that is where your velocity is 0. So if an object is stationary, you'll have a straight horizontal line on the x-axis. So for a velocity time graph, when an object is stationary, you'll have a horizontal line on the x-axis. Then an object can move at a constant velocity in a positive direction, in other words, above the x-axis. So anything above the x-axis is the positive direction, and everything below the x-axis is the negative direction. So if you have like the purple line, a horizontal purple line, okay, you won't have a purple line, but I mean, if you have a horizontal line below the x-axis, then that represents an object moving at a constant speed in the negative direction. So guys, very important. In a velocity time graph, it's different from a position time graph. The moment this line crosses the x-axis, you are moving in a different direction. So above the x-axis, everything is the positive, your object is moving in the positive direction, and everything below the x-axis, the object is moving in the negative direction. It's not the same as on a position time graph. Remember, on a position time graph, direction works like this. It doesn't matter where you start. As long as a line goes upwards to the positive side of your y-axis, that direction is then positive, and anything, even if it crosses the x-axis, anything moving down is in the negative direction. But as we see here, for the velocity time graph, very, very, very important, the x-axis divides the positive direction and the negative direction. So everything, any line, doesn't matter shape, whatever, any line above the x-axis represents motion in the positive direction, and any line, negative, positive, any line below the x-axis represents motion in the negative direction. Okay, so that is just to sort out the directions on a velocity time graph. So, moving at a constant speed, we've done that. Next graph. If an object is moving faster, it will either be like the yellow line in the positive direction, in other words, it is above the x-axis, or if you have the same type of graph, the mirror image, in the negative direction. Or your object can also move slower. So if an object is slowing down, you will have these shapes. So the yellow line represents an object slowing down above the x-axis, so that's in the positive direction, and the purple line is when an object is slowing down in the negative direction. Remember, I'll say it one more time. The x-axis of a velocity time divides your positive direction and your negative direction. What does the gradient of a velocity time graph represent? The acceleration. So if you look at all of these different lines, the yellow ones and the purple ones, you can see that if an object is stationary, the gradient is 0, and that makes sense because the acceleration is also 0. Also, when you have a constant speed, constant velocity, it means your acceleration is 0, and that is why the gradient of a horizontal line is 0. If you have a positive gradient, it means you have a positive acceleration, negative gradient, negative acceleration. So you have a negative gradient, negative acceleration, positive gradient, positive acceleration. Now let's quickly talk about these gradients here, the positive and the negative gradients. And when does that mean your car is moving faster or decelerating? So let's quickly look at this red block. To get a positive gradient, it means you can have a positive times a positive, or you can have a negative times a negative gradient. Now, what does that mean? Let's look at the first option. Positive times positive, this one, means an object is going faster in the positive direction. This is this one. If an object is going faster in the positive direction, so this positive means faster in the positive direction, then you'll have a positive gradient and a positive acceleration. But an object can also move slower, negative, in the opposite direction below the x-axis, and that will also give you a positive acceleration, and that is here. If you look here, this is exactly what you have. An object is slowing down in the negative direction, and then you'll also get a positive gradient, which means you have a positive acceleration. Let's look at the negative gradients. A negative gradient can be discussed as following, or interpret as following. Negative means slowing down in the positive direction. So that is that one, negative direction. So this means moving slower in the positive direction. Then you get a negative acceleration or a negative gradient. But you can also get a negative gradient, this is this one, for going faster in the opposite direction. Then you can also get a negative gradient. So negative gradient, negative gradient. A negative gradient doesn't always mean you always go slower. Remember, this is also a negative gradient, but it represents an object that is moving faster in the negative direction. Right, so remember the gradients of a velocity time graph represents the acceleration of an object. So let's start with the first type of questions with a velocity time graph, the level 1 and 2 questions. This is when you have to describe the motion. Now, when we describe the motion, you need to mention two things. First, you need to mention where the object is moving. Is the object moving north or south or east or west or what? Now, let's read the information there at the top. Nadeem starts cycling from rest, so from rest is there, in a northerly direction. So this line starts above the x-axis. Remember, the x-axis divides the two directions. So because your graph starts above the x-axis, and the story in the beginning tells us Nadeem starts cycling from rest in a northerly direction, that means that everything above the x-axis is north. So that is when Nadeem is driving north or cycling north, and everything below the x-axis will then be the opposite direction, south. So that will be this section. So with a velocity time graph, the x-axis will divide your person or your object's motion in the positive direction. So positive direction is north, negative direction is south, and it is divided by the x-axis. All right, so that is your direction. So we have above the line north and below the line south. North positive, south negative. Okay, so now we need to start describing the motion. The first part of our graph from 0 to 3, the object is above the x-axis, so it is moving at north and it's moving at a constant acceleration north. Now this north acceleration means that the gradient is positive and therefore the acceleration is positive. But we don't say a constant positive acceleration. Please do not say that. Instead of positive, you need to say north, because north represents the positive direction. So do not say moving in a positive direction with a constant positive acceleration. Do not use that word positive. Positive is north, so you need to say north. Then from 3 seconds to 8 seconds, the object is moving at a constant velocity north. Why north? Because it is above the x-axis. Everything above the x-axis, all of this is north. Then from 8 to 11, the object is still above the x-axis. So the object is still moving north. It's still above the x-axis. But now it has a negative gradient, and negative is south, and that is why I say it has a constant acceleration south, because it has a negative. So please do not say it is moving slower with a negative acceleration. We don't say negative acceleration. You need to use the word for negative. For this graph, negative is south. Alright, so you can see that for all of these, I try to say in which direction is the object moving, and is it moving with a constant velocity or is it moving with a constant acceleration. And remember, we don't use words positive and negative with graphs. You need to say the word that represents, like for instance, the positive direction is north. So that is why you have to say north or south for this graph. Then again, not again, but for the first time, the object is stationary. And we know that because this line lies on the x-axis, and that is when the object is stationary. Remember, guys, you have to know these little graphs here on the right hand side. This needs to be in your brain, and then it will help you to identify the type of motion that is represented on the graph. Okay, let's continue from 13 to 14. Now the object is below the line, so now the object is moving south. So here, this can be described as the object is moving south between 13 and 14 with a constant acceleration south. Why with a constant acceleration south? Well, we have a negative gradient. Negative gradient is a south gradient, and the gradient represents acceleration. Then we also again have a constant velocity south. Why is it south? Because it's on the below the x-axis. It's on the negative side of the graph. Then we have a straight line with a positive gradient. The gradient represents acceleration, but the object is still below the x-axis. So the object is still moving south, but with a constant acceleration north. Why is your acceleration north? Because the gradient is positive, and positive is north. We can also calculate the distance, the total displacement, average speed, and average velocity on a velocity time graph. So remember, Nadim starts cycling from rest in a northerly direction. So everything above the x-axis is north, and everything up below the x-axis is south. Now, if you want to calculate the distance and displacement, we need to calculate the area under the graph. I'm going to repeat that. If you want to find either the distance or the displacement on a velocity time graph, you need to find the area under the graph. Now, first we have a triangle, half times base times perpendicular height, and that is 2,25 meters. Then we have a rectangle, length times breadth, that gives me 7.5 meters. Then I have another triangle, half times base. So you can take your graph and divide it into all these shapes, geometry shapes, and then calculate the shape. Now, what is the difference between distance and displacement? Distance is a vector and displacement, no, other way around. Distance is a scalar and displacement is a vector. So when we calculate distance, it is the area under the graphs, but we just add everything together. Why? Because remember, guys, distance is a scalar. Direction does not have an influence. It doesn't affect your distance. So we will just add all these little areas that we calculate to calculate the distance. We just add everything together. And then if you want to find your average speed, you just go total distance divided by total time. So you add up all the areas together, its distance, doesn't matter where the direction, north or south, and we just divide it by the total time, which is 20 according to your graph. But when we talk about displacement, now we must take into account direction. We must take into account the direction. So remember, the x-axis divides all your positive direction. So all of these areas must be positive and all of these areas need to be negative. So if we add them up using a vector addition, all the areas above the x-axis will be positive and all the areas below the x-axis will be negative. So that means that your total displacement will be positive 12 because above the line you get positive 12, but below the line 0,5 times 5 plus 5 plus 0,5 gives me minus 6, negative 6. So positive 12 minus 6 gives me 6 meters, and because I get a positive answer, the direction for my displacement is north. Remember, a positive sign for this graph means your total final displacement is in the positive direction, which is north. So just to summarize quickly, if you calculate distance, distance is a scalar, so we just add everything. We don't mind about the direction, we just add everything. But if we calculate displacement, we need to add everything above the x-axis and subtract that with the areas below, the negative areas, and that will give me the vector displacement. And just one last comment, if the sign of your displacement is positive, it will be north. If it was a negative answer, your direction would have been south. Then in order to find your average velocity, it will just be your total displacement divided by your total time, which is again just 20 seconds there. Also, displacement is a vector, velocity is a vector. And remember what we said earlier, the direction of your displacement will also always be the direction of your velocity. The direction of your velocity will be always the same as the direction of your displacement. So that is how to find distance and displacement on a velocity time graph by calculating the areas under the graph. The last skill, level 1 and 2 skill that you need to be able to master on a velocity time graph is to calculate the gradient which represents the acceleration of the object. So here we have an object moving faster with a positive gradient. Here you have an object moving slower with a negative gradient. Remember what we said earlier is that this negative gradient doesn't mean necessarily that the object is moving slower. This negative gradient means that the object is moving faster but in the negative direction, and that is why you get a negative gradient. But, and this is a big but, this positive gradient here means the object is moving slower in the negative direction. And a negative gives you a positive, and that is why this gradient is negative. So, if we start by asking you to calculate the gradient for the first type of motion from 0 to 3 seconds, you need to, just like any other mathematical calculation, gradient calculation, you need to get your two coordinates. So there's my two coordinates, xy, x1, y1, x2, y2. You calculate the gradient, guys, and this is just math, pure mathematical skills. Now I got the gradient as 0.5 meters per second. Remember, very important, the gradient of a velocity time graph is equal to the acceleration. So the acceleration, the unit for acceleration is meter per second squared north. And because you get a positive answer, it means that your acceleration is north. We also have a straight line here between 8 and 13 seconds. Again, please just do the math. Find your two coordinates and then calculate the gradient using your mathematical skills. Now we can see that we should get a negative gradient here, and we do. The gradient there is negative 1/2. But remember, in math, we're not allowed to leave our answer as a negative. So you need to take away your negative answer and interpret it scientifically. So that negative sign represents the negative direction south. So instead of saying minus 0.5 meters per second, we leave out the negative sign and substitute it with the word meaning or representing the negative direction, which is south. So minus 1/2 becomes 0.5 meters per second squared south. Now let's do one more example, how to calculate the acceleration on a velocity time graph. If we want to find the acceleration on a velocity time graph, last example, let's work here at the bottom, right bottom hand side of your screen. If I want to find this acceleration, I need to calculate the gradient of this line. I can see that that line has a positive gradient, so my answer will be positive, but I'm not going to say positive, I'm going to use the word north, because for this graph, north represents the positive direction. So I calculate the gradient just as I do in math. Please don't overthink it, don't overcomplicate it. Just calculate the gradient as you do in math. So I get a positive answer, 2 meters per second squared north. Now remember, how can you get a positive acceleration below the x-axis? Remember, if an object is moving slower in the negative direction, it will have a positive acceleration. Why? Because a negative sign times a negative sign equals a positive gradient.